Welcome to Lesson 7.2. Today we're going to be talking about solving exponential equations and inequalities. Only three vocab terms to talk about here. We've got an exponential equation, and that's an equation where the variables are in the exponent. We're going to talk a little bit about compound interest, and that is interest paid on the principal of an investment and any previously earned interest. We also have exponential inequality, and that is an inequality where the variables are in the exponents. So to solve exponential equations, we're going to use the equality property for exponential functions. So if we have b as a positive number other than 1, if we have b to the x sub 1 and b to the x sub 2, those are only equal if the exponents are the same. So basically this states that if the bases are the same, we can simply set the exponents equal to each other. This property is quite useful when we're trying to solve equations involving exponential functions. So we're going to take a look to see how that works. So basically what we're going to have to do first is we need to get the bases equal to each other. Okay, that's going to be our first step for these examples. So our first example, we've got 2 to the x is equal to 8 to the third. Now you'll notice that our bases aren't the same. One of them's a 2, one of them's an 8. So what we're going to have to do is we're going to have to try to figure out how to rewrite this so that our bases are the same. So what we can do is instead of 8 to the third, I can rewrite 8 as a form of 2. Well, 8 is really 2 to the third. So I can say that 2 to the x is equal to 2 to the third raised to the third. Now when we've got power of a power, if you remember that, we multiply our exponents together. So really 2 to the x is equal to 2 to the 3 times 3, which is 9. So 2 to the x is equal to 2 to the 9. Now that my bases are the same, I can set my exponents equal to each other. So my answer is x equals 9. A little bit more complex example here. We've got 9 to the 2x minus 1 is equal to 3 to the 6x. Again, to start out with, we have to get the bases to be the same. I've got a base of 9 and a base of 3. So what I can do is I can take 9 and rewrite it as 3 squared. So I've got 3 squared raised to the 2x minus 1 is equal to 3 to the 6x. Once again, I can multiply my exponents. 2 times 2x minus 1 gives me 4x minus 2. So I've got 3 to the 4x minus 2 is equal to 3 to the 6x. Now that my bases are the same, I can set my exponents equal to each other. So I can say that 4x minus 2 is equal to 6x, and I can solve from there. So what I do next, I can subtract 4x from both sides, giving me negative 2 is equal to 2x. Divide both sides by 2, I get that my x value is a negative 1. So x is negative 1. Our next example, we've got 4 to the 2n minus 1 is equal to 64. Again, my first step is that I need the bases to be the same. So I leave the left side, 4 to the 2n minus 1. And instead of 64, I can rewrite that as 4 to the third power. So you do need to be pretty good at being able to rewrite at numbers in different forms. Okay, so now that I've got that, my bases are the same, 4 and 4, so I can take my exponents and set them equal to each other. So I can take 2n minus 1, set it equal to 3, and solve. So I can add 1 to both sides, so I get 2n is equal to 4, divide both sides by 2, and I get that my answer is n equals 2. Go ahead and pause the video, solve this last one on your own, and then hit play and see how you did. You should have rewrote 125 as 5 to the third first. And then multiplying the exponents, you should have gotten 5 to the 5x is equal to 5 to the 3x plus 6. Bases are the same. I can set the exponents equal to each other. 5x is equal to 3x plus 6. Solving for x, you should get an answer of x equals 3. Next, we're going to talk compound interest formula. Okay, the compound interest formula is written on the screen here. Okay, so A is our total amount that you'll need to pay at the end. Okay, P is your principal or starting amount, so however much you started out with. You're going to multiply that by 1 plus your interest rate as a decimal, so make sure you've got that, your interest rate turned into a decimal, divided by the number of times the interest is compounded per year, and then you're going to raise that parentheses to the number of times interest is compounded per year times the time in years. Okay, so principal goes here for P, interest rate as a decimal in for R, number of times you compounded a year goes in for N, and then T is always time in years. Some common compounding periods that they will use, it won't be all of them, but this will give you some kind of an idea. If they use the word annually, that's once a year. Semi-annually is twice a year. Quarterly is 4 times a year. Monthly is 12 times a year. And daily is 365 times per year. So if we have an investment account that pays 4.2% annual interest compounded monthly, okay, if we put $2,500 in this account, what will the balance be after 15 years? Okay, so we got to plug in our values in to our equation. P is our starting amount, that's 2,500. So 2,500 here. Okay, and we'll always have 1 plus our interest rate as a decimal. Our interest rate is 4.2%. That written as a decimal is 0.042, because again we move the decimal to the left 2 spots. For N, it's the number of times it's compounded per year. It's monthly, so monthly tells us to do 12. And then finally, the T is the time in years. If we're doing 15 years, we're going to multiply that by 15. Okay, so 12 times 15, we'll clean this up a little bit first. Okay, 12 times 15 gives us 180. Okay, so I can type this into my calculator just the way I see it, and if I do that, I will get an answer of $4,688.87. We round it to 2 decimal places because we are talking about money. Our next example, we've got find the account balance after 20 years if $100 is placed in an account that pays 1.2% interest twice a month. Okay, so again, plugging in our values, start out with our principal amount, that's going to be 100. Okay, we fill in the rest, 1 plus. Okay, our next is our interest rate as a decimal. Okay, we've got 1.2%, so that as a decimal is 0.012. For N, the number of times it's compounded a year, if we compound it twice a month, and there are 12 months in a year, it's going to get compounded 24 times. So N is going to be 24. Finally, T, our time in years. If we have 20 years, our value for T is going to be 20. So cleaning this up before we type this in, 100, 1 plus 0.012 over 24. If I multiply 24 and 20 together, I should get 480. So if I type that into my calculator, I should get an answer of $127.12. Again, rounding it to that nearest hundredths because we are talking about money. Our next example, a certificate of deposit, or a CD, pays 2.25% annual interest compounded bi-weekly. That's every other week. If you deposit $500 into this CD, what will the balance be after 6 years? Okay, so again, filling in our values. Our principal, we start out with $500, so 500 is going to go out front. Our interest rate as a decimal, it's a 2.25%, so moving the decimal to the left 2 spots, it's going to be 0.0225. For our value for N, the number of times it's compounded per year, bi-weekly, again, is every other week. So if it's every other week and there's 52 weeks in a year, that means we're going to compound it 26 times. And then finally, our time in years, they want to know for 6 years, so we're going to put in the 6 there for T. So cleaning this up a little bit, should have 500 times 1 plus 0.0225 over 26. If I multiply 26 and 6 together, I should get 156. So if I type that into my calculator, I should get an answer of $572.23. Go ahead and pause the video and solve this one on your own, and then hit play and see how you did. The equation you should have gotten is 700 times 1 plus 0.043 divided by 12 raised to the 12 times 7 power. 12 times 7 is 84. If you type that into your calculator, you should get that after 7 years, there's $945.34. The last thing we're going to do is we're going to solve exponential inequalities. And to do that, we're going to use the property of inequality for exponential function. That works the same way as the property of equations for exponential functions, but we're going to use the inequality instead of the equal sign. So if we have 2 to the x is greater than 2 to the 6th, then we've got x is greater than 6. So once the base is the same, we take the two exponents and we use the same exponent that was, or the same inequality symbol that was in the problem. So we set those and then we solve for x. Our first example, we've got 16 raised to the 2x minus 3 is less than 8. Okay, the first thing I need to do again is to rewrite it so the bases are the same. I can write 16 and 8 in terms of 2's. So 16 I would say is 2 to the 4th raised to the 2x minus 3, and 8 is 2 to the 3rd. Multiplying my exponents on the left, I should get that it is 2 raised to the 8x minus 12 power is less than 2 to the 3rd. Okay, once my bases are the same, I can use the exponent. So I'm going to say that 8x minus 12 is less than 3. Solving, I can add 12 to both sides, so I've got 8x is less than 15. Divide both sides by 8, I would say that x is less than 15/8. They will also use fractions like they do here. Okay, so if I have 3 raised to the 2x minus 1 is greater than 1 over 243, one way that I can rewrite that without using a fraction is I can say that 243 is being raised to the negative 1 power. Now I can rewrite 243 in terms of 3's. Okay, and the way I do that would be 3 to the 5th power. Okay, so now I can multiply my exponents. I've got 3 to the 2x minus 1 is greater than 3 to the negative 5. Once my bases are the same, I go to the exponents and I use my inequality. So I would say that 2x minus 1 is greater than negative 5. Solving for x, I can add 1 to both sides. 2x is greater than negative 4. Divide both sides by 2. I get that x is greater than a negative 2. Our next example, we've got 2 raised to the x plus 2 is greater than 1 over 32. Again, I don't want to use exponent or the fraction, so I'm going to say that the right side is just 32 to the negative 1 power. I need to rewrite 32 in terms of 2's, and I can do that by rewriting it as 2 to the 5th power. So I've got 2 to the 5th raised to the negative 1 over there. Multiplying the exponents on the right side, I should get 2 raised to the x plus 2 is greater than 2 to the negative 5th power. Once my bases are the same, I can go to my exponents. I can say that x plus 2 is greater than negative 5. Solving for x, I subtract 2 from both sides, telling me that x needs to be greater than a negative 7. Go ahead and pause the video and solve this last one on your own, and then hit play and see how you did. First thing you should have done is rewrote 64 as 4 to the 3rd. Multiplying your exponents, you should have gotten 4 to the 2x plus 6 is less than 4 to the 6x minus 12. Setting the exponents together with the inequality, 2x plus 6 is less than 6x minus 12. You should have gotten as a simplified fraction, x is greater than 9/2.